Hey everyone, let's go to part four. Going forward, we looked at joystick input, coordinates, location control. Once we're able to move around in our world, how do we know where we're at? So I kind of built up the system to kind of divide the world into zones. In a typical type of game engine like Unity, Unreal, you might be familiar with things like trigger volumes or collision volumes, which will fairly easily let you determine if your first person character has walked into a certain area. Um, I kind of batted around ideas at the beginning of how exactly to do that here. In the beginning, you're thinking in the same kind of physics way. That's possible to also do a kind of collision volume in TouchDesigner with bullet physics or some other types of physics. It's really not a performative way to do things though in TouchDesigner. So some other solution had to be found. So what I came up with, if we just dive into zone tracking here, is a solution that I called Milestones. So I'm essentially plopping little points along my world, and I have about 237 of them, and storing TXTYTZ as well as RX and RY data for all of these. And then at the core of my zone tracking system is really comparing my camera position. So here I'm grabbing that from my FPC location control Xforms chop, which we created in the last video. And I'm comparing my current position with all of these milestones. And this is using the object chop to get the distance between those. And essentially finding out what is the point, what is the milestone that I'm closest to. And from that, I can determine what zone I'm in. So I found that to be a fairly performative way to do things. But maybe to start with, if you're not familiar with the object chop, here's just a brief little lesson in that. So I've got these little visualizations here, but really all we need to look at is really just two different chops being input to object. Actually, let me just delete that for a second. And so both of these noise, it's just, I've got just, TXTYTZ with random noise. If we get the object, and then put one, so object chop only accepts two inputs. And so at first, if you go output, so it's giving you various transforms. So it's expecting kind of from one operator to world coordinates. We can play around with this compute. There's a lot of these that I haven't really used some of these other parameters, but on measurements, this gives us some pretty great options here, and distance is what we want. So it's as easy as that, as long as your channel names match these things here. So TXTYTZ is what we care about. Both are coming in. So object chop is comparing those coordinates and give me the distance between them. So we can see, I'm just random here. So if I can move that around, we can see different distances are popping around. So that is super cool to get the distance between things. But what I'm doing, I'm not just comparing single samples, right? I'm comparing pretty like long sample lengths. So what we can do is, let me just copy that. Let's go down here and let's do maybe like 99. Let's change that to a sparse. And we'll do a different C, doesn't really matter. And I'm going to do the same thing. Oops. So one there, and an object. I need to go output, measurement distance. Okay. So what's happening here? Oh wait, let's get rid of position. Okay. So this is only giving me the distance for the first sample. I want to because each of these have 100 samples, right? I want to get the distance for all of them. We need to go into the channel tab, and instead of current frame, we can do start end and select samples. I know I have 100 samples coming in here, so I could do that manually, or you could do a kind of smarter way. Might be something like me dot inputs dot num samples and then -1. So this would be saying me to input 0 would be whatever's input to input 0. How many samples does it have in the -1? So now once I increase this start and end, I have a nice beautiful curve of distance between all of these points, which is great. And I want to, let's see, do unit samples, and let's do dot per sample. So what sample index is the closest between these two things? Our old friend analyze. And for a lot of my students do a lot of sound visualizations, so we kind of equate analyze chop with RMS power. But I encourage you to look at the operator snippets if you haven't already for analyze. There's all these other functions are really great. So I want to do index of minimum. And there we go. So the point that is closest is sample 43. If I zoom in here, we can see. There we go. That is the closest point. Great. What is the point that is farthest away? 10. And we can confirm that. That looks about right. So index sample number 10 has the greatest distance. Okay, so in a nutshell, that's what we're doing. With one extra complication. So I've got this table of milestones, which really for these, I actually don't really care about arcs RY, because that's not really affecting the distance between them. But I've got 237 there. My camera only has one sample, or there's only one certain camera position at a given time. But I want to compare my camera position to all 237 milestones. So I'm putting my camera position into a stretch top here, and I'm just stretching it. I'm just looking at the number of samples up there. So it now has equal number of samples. Both have 237. And once they all have the same names, they have the same number of samples, into our object chop, making sure the object chop goes all the way. And now I have this beautiful graph where I can see which milestone I'm closest to. So let's fly through a little bit. And actually what I can do, let's get a select so we can see what we're doing. Let's go into main out1. Cool. Okay, so let's see how we can see all this stuff. Okay, so let's see if I can fly. And maybe I'll make myself a little faster. Okay. So, as I'm going through my world, you can see the closest milestone is steadily changing. So right now I'm closest to milestone 46 based on this graph here. Steadily being closest to progressively higher number of milestones. Okay, but what are the milestones? How do they create the milestones? What exactly is happening with them? Let's go up to main, because the milestones, the visualization of the milestones lives right here, which I normally don't need it, so I just don't even cook it. But there we go. Look at that. So this, I didn't want to make like a Sonic the Hedgehog type of thing, but theoretically, right, these could be like rings that you collect. But really, they're just for the purpose of kind of tracking our progress through the worlds. So I don't have to go through the milestones, but I just need to know which milestone am I closest to? And let's go back into our zone tracking. So all of these milestones are being generated from this table here. And we can see as I progress through. So again, I'm closest to these various milestones. Great. How did I place these milestones? Because that seems like kind of a hassle to place all of these throughout the world. To do that, normally this system, which right now I have deactivated, but let me just reactivate it. And I've got this button here, Store as Milestone. So I set up a system kind of in the beginning where I could just fly through my world, and with this chop execute activated, I hit my Y button, which is B4, and that will click button 1. Okay. So button 1 is clicked. What happens when that's clicked? I've got this panel. I didn't strictly need that, but select. Okay, then that's going into this chop execute. So when that button is clicked, that looks at this select operator and looks at these 5 parameters. So my select 1, that's my camera position coming in. So I'm grabbing these 5 parameters and assigning them to these variables temporarily. And then I have this table. So I'm getting how many rows are in my milestones table. And through our little magic code, or this little Python append row, I'm appending my values. So these would be my current camera values. Appending those values into a single row. And which row am I appending it to? Well, it's the number of rows minus 1. So right now I have 237, or I should say 230. Is that 237 total? Yeah. So this is essentially appending it to the final row. I don't want to mess up my proper milestones table here, but to show how this works, let's do this. Let's copy and paste. I'm going to deactivate that. I'm going to make a new table, and I'll just call it a demo. And now in this execute, we'll tell it to write to the demo table. And for now, it doesn't even matter that I just have one cell if nothing's really labeled yet. But let's see what happens. I've got this activated now. Okay, great. So what's going to happen? So as I move around, I'm going to hit the Y button. Right there. I hit Y. And lo and behold, when I did that, it took these values and it appended a row in my table with those values. Pretty awesome. And then I just manually, I had written these labels here because that was helpful to have those labels. And then, the way I did this, I kind of, okay, go forward a little bit more, hit Y again. Go forward a little bit more. Okay, so it was, creating these milestones is really just a process of taking a little hike through my world and then hitting Y a whole bunch of times and filling up that table with, I had over 200 milestones. So this just in general, I guess it's the coding principle, but also it's kind of the way I like to work where to me it makes more sense to spend a lot of time to figure out, to engineer a system, and then to actually act on that system. It's really just, it's a gesture, right? So now I have this system I can easily, if I do this type of project again, I can very easily populate milestones within my world super duper quickly in a very gestural way with the milestone system. So I'm happy with that. Let's just get rid of that. Okay. And before I forget, I'm going to deactivate that because I had the Y button for my lost beacon, which I talked about in some other videos. So I don't want to accidentally create new milestones now because it's done. Okay, cool. So once we know what milestone we're closest to, actually, maybe now I'm going to slow down because when I get kind of fast, I get kind of jittery. There we go. Okay. So we know what milestone we're closest to. How does that translate to zones? Because you can see here I've got roughly, how many is that? Like 10 different zones. As I go through these, you can see I kind of, I think this is the beginning of zone E. If I back up here, I should go back to zone F, I think, maybe. Or maybe this is zone F up there. Let's go forward a little bit more. There we go. Okay, so that triggered zone F. So what did that? When I'm getting my closest milestone, I have this system of logic chops. One logic for each zone I have. And I mean, I love logic chops. I use them all over the place. And what's happening here is I have this off when outside bounds convert input parameter, and I set my bounds to the range of milestones that I want that zone to be in. So if I'm closest to milestone 1 through 10, then zone A, this logic will be activated. So well, I'm in zone F right now, right? There we go. So I am closest to, which one was it? It was milestone 160, which means I'm within the bounds of this logic here. So that one turned on. As I back up a little bit, I should go back to, there we go, zone E. So now I should be probably closest to 157. There we go. Right. So now I'm within those bounds. So that's how I'm determining which zone we're in. This zone I there's an extra little complicated thing that we don't need to look at. So that's pretty straightforward, but which I thought was a pretty elegant solution. Merging all of those, doing a shuffle, sequencing all channels so that I can then use and analyze to get the index of maximum. So the index will give me just the number of zone. Actually, I could have, now that I'm thinking about this, I think I'm gonna kind of improvise here. I could have also done a fan in, I think, maybe. Yeah, I could have just done that. That does the same thing. I forget why I did that. Maybe there's a reason, maybe not. I don't know. But really, that's only taking 0.004 milliseconds. That's taking about the same. So I'm maybe wasting 0.004 milliseconds by doing 2 operators instead of 1. And then I'm adding 1 to that because for a lot of these, for both the milestones and my zones, I am not 0 indexed. I'm 1 index, which means the first one starts at 1. For milestones, that's because my first milestone is at row 1 because I have these labels here. And we'll see kind of the same way. I have a zone table where the first row is actually labels. So the first zone is in row 1 of like a zone table that I have. And then this little switch is just in case I wanted to do manual triggering of zones. So right now I'm set to cam position. And that's it. So that's how I'm determining which zone I'm in. What happens when you change zones? For the most part, the big thing is I've got audio effects that are changing. So let's turn on audio. Actually, there we go. Got a black hole, so now it's going to OBS. Okay, now we should hear it. So if I just do this again, let's do what I did before. So I'm back in zone E. And actually, one other way we can debug this. Let's go here. Let's go to main. In addition to the milestones, I've got somewhere, I've got a label. There we go. I've got perform as well as a little label for which zone I'm in. So I can plop that in here also. And actually, it is currently being cut off a little bit. There we go. Okay. Okay, I'm in zone E. There's a certain audio playing right now. Now I went to zone F. And a new audio file has faded in. So how are we doing that? Let's bring the audio down a little bit so we can hear. So let's go and see what's happening. So on the audio container here, I'm grabbing my current zone, which is at the end of my zone tracking. And I'm sending that to, let's go into this breathing rocks here. So I've got different families of sounds. These 4 different audio files that I created that I'm calling just breathing rocks sounds. So when I am in this certain zone, I want the 3rd breathing rocks audio file to be playing. So how are we doing that? So I'm basically from this zone 6, which is, that would be zone F, play audio file number 3, and so that's doing this little action over there. So that is looking at this table, which I manually filled. So I've got my different zones. I've got my audio families here. So right here we can see with my Breathing Rocks family of sounds, depending on which zone I'm in, which audio file do I want to be playing. So I can control that. I can control the mix. So this mix info is going over to my setting the gain for each of those sounds. So some like 0 just means I want that family of sounds to be turned off, a little bit quieter, a little bit louder. So for each zone, I can have control over those. So I'm in zone F right now. So that is grabbing this Breathing Rocks file number 3 and setting the gain to 0.2. So if we go back up here, Breathing Rocks. So that's what this select. The select is looking at that table I just showed you. Which row of that table we look at the current zone row, and then which column we look at Breathing Rocks. So that's how I'm grabbing the number 3 right there. And then once we grab the number 3, dat execute. Whenever that number changes, it looks at these buttons here, which are in a container called selected BR. And I'm concatenating a string here. So this dats return a string value. So this dat00 is giving me, it says the number 3, but technically that's a string data type. So this is essentially creating this this code selected br/button 3, and is clicking that button. Cool. And we can see that was clicked. Radio button comes out here, and again, I'm kind of adding, radio buttons are 0 indexed, but I wanted them to be 1 indexed, so I'm just adding a number 1 to that. And again, with the logic, so each of these logics is in charge of which the bounds. So if I'm in, if I've selected file number 1, that's going to turn on. File number 2, file number 3, file number 4. So we can see this logic is on. That audio file is playing. And beautiful. That's how we can turn things on and off, depending on where we're at. In the audio tutorial, I'll go into some more of the details of this. This is kind of adding a little more complexity to the way things fade in and out. Actually, you don't want things to just turn on and off automatically because that will sound bad. But I think that's pretty good for that, right? So also here, this is where we're getting the gain value. I've just got maths at the end of all of these things. So there you go. That's how zone tracking works. Hopefully you can use it. Cool.